Hello and welcome to our presentation. I am Dr. Lorans Alabood, and today I'll be presenting our paper, From Letterboards to Holograms, Advancing Assistive Technology for Non-Speaking Autistic Individuals with the HoloBoard. 1% of the world population are on the spectrum of autism, 30% of which are non-speakers, which means they cannot use speech as a mean for communication. Most non-speakers are unfortunately not provided with effective language-based alternative to speech. Two-way communication is a key factor for effective and open-ended conversations. So, how do non-speakers communicate then? The first and the most common method is augmentative and alternative communication, AAC. These are devices equipped with multiple categories of images that would help non-speakers to convey a message. As you would imagine, this would be effective for many people, but is also limiting in a way that you cannot have a two-way conversation using images only. The other way is spelling on a letterboard with the help of communication and regulation partners. This method requires more training, and it requires a person to train with a professional CRP to develop the motor skills to point and isolate letters on physical letterboards. The CRP would hold the letterboard, position it in an optimum place for the participant, read aloud what's being spelled, and also assist with emotional regulation. In our research project, we wanted to help non-speaking autistic people to achieve digital communication using an application that we built called HoloBoard. The first objective of the HoloBoard is to facilitate digital communication, particularly two-way communication. The second objective is to leverage existing skills, where the virtual letterboards should look and feel very similar to the physical letterboards. Thanks to head-mounted augmented reality headsets such as the HoloLens, this goal is accomplishable. Third, we wanted to support various user categories, where users, their CRP, and even family members can join a virtual spelling session where they can interact with virtual objects simultaneously. And lastly, we want to address the problem of lack of haptic feedback. For a starter, we introduced an initial version of the application, and we evaluated this with 5 participants with 5 different motor skills profile in the city of Calgary, Alberta, Canada. We created digital versions of 3 plastic or stencil letterboards, and then we got them to be more customized by the CRP, where they can change the position, location, and rotation of letterboards. We want them to be interactive just like the actual physical letterboards, and add more layer of interaction where participants could spell letters and see the audio-visual feedback while they're doing that. And also we wanted to make them multiplayer. Our pilot study yielded positive results, and overall we received positive feedback from our participants. Based on that, we reiterated our design and introduce HoloBoard 2.0, which we will go over in this section of the presentation. CRPs have much more flexibility now in terms of customizing the letterboard, choosing different types of letterboards, changing color, and many more. The letterboards themselves come with additional features that make them closer to a text editor or a mini version of a text editor. On top of the 2 most famous letterboards, the stencil board and the laminated paper letterboard, we added 4 more different letterboards for different users. That's just to satisfy the familiarity objective that we set earlier. We worked closely with our participants to design the audio-visual feedback, from hovering over a letter all the way to pressing and releasing. And the most important feature was detection and providing feedback for overshooting, where the letters get locked and notify the user to retrieve their hand. it was important for us to integrate cross-reality, where multiple user categories can interact with the application at the same time, from headsets to handheld AR devices. CRPs and users now can work together to practice spelling in the virtual world, while this entire session can be observed by a friend or a family member. Accomplishing our project goals required working with various Unity packages and services. We realized the difficulty of integrating all these packages in one application. Therefore, we created a package called Simple Share, and we made it available publicly and open source. This allows developers to create this sort of cross-reality applications and have easily set synchronized shared real-time experiences across devices. We designed the training for our user study to go through 5 phases. The first phase, participants have to locate these single buttons on the corners of the letterboard. This is the first type of interactions they would have with the system. In the second phase, they go and locate the letters on the corners of the letterboard and the one in the middle, using mirroring exercise where they find the letter on the physical letterboard first and then on the virtual. In the second phase, we ask them to spell short words that start to progress in difficulty. With these spelling tasks would be assisted, where the required letters would be pulsing. In the next phase, we remove the assisted feature and we ask them to spell different set of words. And in the last phase, we ask them to spell their name and 4 other words completely on the virtual letterboard, no mirroring. We conducted our user study in 3 locations in the US: Cincinnati, Ohio, Philadelphia, Pennsylvania, and Hardin, Virginia. We recorded various types of data, from questionnaires and video recordings from the first-person perspective. And we allowed participants who wanted to go beyond the 5 training modules to do so if they wished. We use NVivo software for inductive and deductive video coding for the purpose of thematic analysis. And we report our results in the following metrics. Let's look at our initial results. Success rates. So for phase 1, we see most participants hit 100% success rate except for 1 participant. For phase 2, we see similar result. A few participants had less success rate in this phase. And then in phase 3, they went back again to a higher success rate. In phases 4 and phase 5 as well, we see an improvement overall. So we clustered our results into 3 main categories here: partial training completion, 100% success rate across all phases, mid-training dip followed by 100% success, and 100% success initially with a slight dip towards the end. As we can see here that most participants would experience increased spelling speed over the 3rd, 4th, and 5th phases. These are the phases where they moved into spelling words. The group average overall was increased as well, indicating to an improvement in such short period of time. Investigating the nature of successful interaction was an important aspect, because we wanted to know why they were successful and how. On the left side, we see the participants, and we looked at every single interaction and we coded them. So as we can see, 187 of these interactions were completely independent. 31 interactions required queuing, and 11 interactions required mirroring, where the physical letterboard was brought up. And then lastly, 24 participants required verbal promptings. When we look at when these interactions how these interactions were distributed through the phases 3, 4, and 5. We notice that as we go more towards phase 5, we see more independent interactions and less of the support needed, such as cueing, prompting, and mirroring. 14 of our study participants voluntarily wanted to continue using the HoloBoard post-module. The graph here shows results from multiplayer mode interactions, meaning the participant and their CRP both wearing the headsets. We can see that we observed multiple and different types of interaction, from spelling short answers all the way to providing feedback on the HoloBoard. Five of our study participants continued to use the application post-module spelling in a solo user fashion. As we can see, we observed three types of interactions here: short responses with prompts, full sentence responses with mirroring, and independent short responses. The video here shows a sample of one of our participants trying to give feedback about his session using the HoloBoard only. As we can see, the participant is using the HoloBoard same fashion as the physical letterboard, where there is no space bar. So there is no spaces between the words. If you're interested in learning more about our data, we made it available publicly on a data dashboard via Tableau Public. After looking at our results, we wanted to see the factors contributing to the success of our participants. The first set of factors related to the familiarity and motivation, where participants were familiar with the interface, familiar with the mode of interaction, and also the promise of more independence down the road was motivating for our participants. The second part has to do with the design-related factors, such as the audio-visual feedback, the overshooting detection, and reading aloud with a familiar voice. The third has to do with the sense of agency, where studies show improving the sense of agency can improve motor control, which might be the case for our participants here. Lastly, technology-related factors. For some participants, the headset improved their focus and reduced distractions. Others appreciated the micro movement of the letterboard and the potential effect of a frame rate. Now let's talk about the limitations of our study. First, we recruited 5 participants in Calgary. This is for our pilot initial study, and then 24 participants when we toured 3 cities in the United States. We only worked with fluent letterboard users. And finally, we only worked with English language speakers. In terms of the conclusion for our study, we learned that leveraging gained experience was an important factor for adapting this technology. In 20 minutes only, we managed to get people to spell 5 words at least completely on the virtual letterboard. 14 of our participants went on and used the letterboard for more open-ended spelling. Familiarity was a key factor in our study. Collaborative workspace where the participant, their CRP, and in certain times even friends and family members joined the session was an important factor as well. Careful UX and UI design, particularly for the user interactions, was an important factor as well. Enhancing the independence for many, but not all members for this community. In other words, while we understand that this technology helped the vast majority of our participants, we have to acknowledge that certain participants could not continue as they could not tolerate the device. For our future work, we are in the process of finishing a long-term training where we've trained participants for over 4 or 5 months to use the HoloBoard only. Another future work could revolve around the concept of having a virtual CRP who exists in a completely different physical and geographical place. We also want to, at some point, to integrate tailored text prediction. Thank you so much for attending our presentation.